Dear folks, hello again. So today I'm gonna solve some examples about this time geometric series, and we're gonna just cover some examples about the geometric series. And the first, of course, we know what a geometric series is. We're just talking about the sums of the form m from 1 up to infinity a times r to the power n minus 1. And we know we have two options, just divergent if absolute value of r is greater than or equal 1, and it convergent, and it converges to, we just say a over 1 minus r if absolute value of r is less than 1. So that's really what we know about the geometric series. And here you can just see a is just our first term and r is the common ratio. So we're just gonna go over examples of this type. And the first example, I can just say, let's just say find the sum if it exists. So this is, let's say, the question, and let's say this is example 1. So the problem is just find the sum if it exists for the following example. So example 1, look at this sum: 6 minus 9 over 2 plus 27 over 8 minus 81 over 32 plus, and so on. It's about this sum. And if you really take a look at this example, you're going to see there's a common ratio between them. Like if you want to get 9 over 2 from 6, you need to multiply it by a negative 3 over 4. If you multiply that, will be 18 over 4, which is 9 over 2. And if you multiply here by negative 3 over 4, you're going to get 27 over 8. If you multiply by negative 3 over 4, you're going to get 81 over 32. So you see, this is geometric, and the first term is just a, which is 6, and common ratio r is negative 3/4. And as you see, absolute value of r is just 3 over 4, which is less than 1. So that implies that this series is convergent. It's convergent, so it converges to a number. So in this case, we can just say converges to a over 1 minus r, and a, we already know that's 6, and then r is 1 minus negative 3 over 4. So that will be 6 over, you can just see 7 over 4. So we can write 6 times 4 over 7, you flip and multiply. So the answer will be 24 over 7. So that convergent, and it just converges to 24 over 7. So this is the first example. And let's move on to the next example. This is example 2. Again, the same type of problem. Find the sum if it exists. So this is sum, n starts from 1 and goes up to infinity, and it's just 3 to the n over 5 to the power n plus 1. So this is the given problem. And guys, really, if you want to see the common ratio clearly, you can just try to find that constant whose exponent n is just taken. And in this case, you can really take 1 over 5 out, and you can just say, well, okay, I have the sum n starts from 1 up to infinity. So you can write this one as 3 to the n divided by 5 times 5 to the n, because it's n plus 1. So you can basically just write this one as sum n from 1 up to infinity. That's just 1 over 5 times 3 over 5 to the power n. So this is geometric, you can just see. Or you can really expand the first couple terms, and you're going to see each time you're multiplying that by 3 over 5. So this is really basically my r. Although it doesn't look like the standard form, the power n minus 1, still you can just see, like if you write couple terms, that will be the first term will be 1 over 5 times 3 over 5, plus the second term will be 1 over 5 times 3 over 5 squared, and then the next term will be 1 over 5 times 3 over 5 cubed, plus, and so on. We can really see that, like each time you're multiplying by 3 over 5. So the first term from here, you can just see the first term, a is just 3 over 25, and then r, the common ratio, is just 3 over 5. So this is how you see. You really expand some terms, but you can see you can really do that from here. So that will be like 3 over 25 times 9 over 125. Each time you will be multiplying by 3 over 25. You can really see this by expanding this one as well. I mean, if you would like, I can just really do that here. If you plug in 1, you're going to get 3 over 25, plus if you plug in 2, you're going to get 9 over 125, plus if you plug in, for example, 3, that will be 27 over 625 each time you multiply, so, and then so on. See, you just come up with the same thing. The first term is 3 over 25, and the common ratio is just 3 over 5. And you can just see absolute value of r is just 3 over 5 less than 1. So this series is again is convergent, and we can just say it converges to a over 1 minus r. So a, you can just see a is 3 over 25, and then 1 minus r is 3 over 5. So that will be 3 over 25 divided by 2 over 5. So the answer, we will have 3 over 25 times 5 over 2. These two will cancel, and you're going to get 5 here. So the answer will be 3 over 10 for this problem. And it's convergent, and it converges to this number. So that's the sum. So the next example, I may just say that could be, we can just say this is the last example for just this video. But this one is just, it's number 3. I can just say this is something which is divergent, and like the sum n from 1 up to infinity, this time let's say 3 to the power n plus 2 divided by 2 to the power n. Like you can see, this time you can really take that square of 3 out if you want, or you can really write each term. For example, let's just do it in that way. If you plug in 1, you're going to get 27 over 2. Plus, if you plug in 2, that will be 81 over 4. So if you plug in 3, that will be 3, so 2 to 5, that will be 243 over 8, and so on. Like each time you can see, if you want, you can expand in this form. Like each time you can see you're multiplying by what? A 3 over 2. Each time you're multiplying by 3 over 2. Or basically, because of the squared, you can really write this as sum n from 1 up to infinity. That might be 9 times 3 over 2 to the power n, and that could be another way to see the common ratio. But you can see the common ratio r is just basically 3/2, and then the first term is just from here. This is your a is 27 over 2. So you can see absolute value of r is 3/2, which is larger than 1. So in this case, you just say this series is divergent. So divergent means it's not sum is not a number. So even you can see r is 3/2. You can plug in that formula, a over 1 minus r. But since it's divergent, you don't compute it because you know it's not a number. The sum is not a number. Okay, thanks for watching, and I'll just go over more examples next time. And bye.